Today we're going to see what we can get out of random forest. We're going to try to do some fine tuning, look at some of the different options, both the ensemble options for random forest and the individual tree options. So I'm on the GitHub page for this class, you could say. So this is where I find a lot of the data sets and the code because recall that it is partially based on this hands-on gradient boosting with XGBoost and scikit-learn book published by Pact. Book totally optional, but again, we're using this GitHub page, which you can search on Google to find to access the data. This is actually, we're now in chapter 3, which is the random forest chapter. So if you click on that, okay, chapter 3 link, and then we're going to look at we're going to use this bike rentals cleaned data set. Okay, so to access that, I simply click on it and then click view raw. And now I'm going to copy in the URL, Command C, open up a new Colab notebook. Okay, so go to your colab.research.google.com, click on new notebook. Make this a little larger. And let's title this, maybe RF's tuned. And in case you're wondering about the tuning, the idea is this, in order to kind of bring your machine learning to the next level, it's not just about using the models that are provided, it's about really kind of doing your best to fit them to the data, but not overfit them, find that right balance, and to find the right numbers, the inputs for the hyperparameters that you can change. So first we need the data, so we'll put URL in quotes, like Command V, paste in the URL, and then do the standard import pandas as PD, df equals pd.read_csv, put in the URL, and then let's go ahead and look at the first 5 rows. All right, so we're loading in our data here. Now the bike rentals data, there's some different ways that you can actually use it for machine learning. So if we look in this particular case, we can see that if we scroll down to the right, we're trying to predict just the number of bike rentals, which is the count here, okay? We're going to use all the other columns to do that. Now, the first thing that, and the other thing is, this is a cleaned data set, okay? But if you ever want to know, you're not sure if it's cleaned, you can always put in df info. And then let me show you what this does. It tells you the column types, all of them. You see int64 and float64. Those are all of them, so they're all numerical. And also indicates, look, there's 731 rows, and these are all non-null, which means there are no null values because they all have the same number, 731. Usually when they're all the same, you can be pretty sure there are no null values. But note that that does match these 731 entries or rows. Okay, so you can use dfinfo for that, and I'll make a little note of that. So just confirming that df is ready for ML, and we want no null values plus all numeric columns. Okay. And here, clearly, we're just loading in the data. I'd like to put these headers in for you all. And now let's jump into random forest. All right, so let's get a baseline score here. Now, I want to go ahead and shuffle it because I'm going to use both cross-file score and grid search CV. So, it's nice to just, because they don't have the same splitting techniques, to actually use k-fold to do the splits initially. All right, and the other piece that we need to know is, are we doing a regressor or a classifier here? Well, if we look at the column that we're trying to predict, you see count here. We see a bunch of different values, right? It's trying to predict how many bike rentals there are in a given day. So this should be a regressor because we're just getting as close to these values as we can. Okay, So let us now start with some imports. Imports for ML, you could say. Okay, so first of all, the random forest. So that's from sklearn.ensemble. And then we're going to import the random, there it is, random forest regressor. We're going to import from sklearn.model selection. This is where we can get the k-fold, I believe. Import k-fold. I wait sometimes, right? Because if you wait and Colab prompts you, then you actually know that it is there, right? It could be like, just to show you, if I thought the random forest regressor was here, see how it's not giving that as an option because it doesn't live inside of model selection. And so again, sometimes it doesn't always show it, okay, but it often will. I think this is also where cross-file score is, yes. Okay, there may be some other things that we need, but to get started, we definitely need these, so we'll start with that. So when I press Shift Enter, then these are ready. And I did this, I think, last time. I'm so ready to jump into machine learning. I forget that we actually need to split the data. So split data into X and Y. And then we can do that by X is going to be using index location, all rows, all columns except the last, and Y is going to be all rows and the last column. Okay, that should work. And now I think we can go ahead and build our first model, but we're going to split it first using k-fold. Okay, so the way that works, we just say k-fold. Okay, you can say kf. Right, I can call it whatever I want, but now I'm going to implement k-fold. And you see here that I'm actually going to write it in even though the default is there. Just it's nice to know what it's actually called. It's called in splits. And the default is 5. I sometimes just go with the default. I mean, you can analyze reasons why maybe you could do differently. I can tell you that standards are 3, 4, 5, 10. Those are all standard. So let's just go with the default of 5. But now we're going to shuffle this. Okay. Now, I think it's interesting that the default here is false. And the reason why is I'm not sure what the advantage is to not shuffling. There's probably some, the fact that it's the default, there's some very good reason. But in this case, we want to shuffle, and here's why. We did this before and got huge gains just from shuffling because these are dated. And sometimes the splits, they may have the dates chunked together. So it's just more random, meaning when I say it's more random, right, these are sequential, this data is. And there's something to that, but this instant preserves the sequence, and it has to do with the splitting of, test data and training data. And if, let's say if all your test data is in, I don't recall what this year is, right? Let's even pick a month. They're all in August, but then so the training data is all August and the test data is all January. That's not going to work very well. Okay, so it's been shown that with this data set, and I think with dates in general, shuffling is a good idea. Okay, so what we're doing is we're setting up, you could say it's called k-fold, setting up splits. What's called shuffled splits. Shuffled splits, okay, for both, this is the key, cross-file score and grid search. I think so, okay. And grid search CV. All right. This is the whole point, that it gives us the same fold. And it does, you can shuffle without k-fold, but kind of a nice little bonus. You can do it with k-fold. Okay. Next, let's run this, make sure it's good. Okay, now we're going to score initial model. Okay, so score initial model. using cross-file score. All right. Okay, so recall how to do this. What you actually get first are really the scores, okay? And we're going to get these scores by using cross-file score, all right? Now, let's look at the inputs, okay? First is the estimator, right? And the estimator here is the random forest regressor, okay? You know, in order to keep this a little less crowded, sometimes I'll just do it up here because we're going to be looking at making adjustments to it, right? To start with the initial model, we're not going to change anything, so we're going to leave the defaults. So inside of cross-file score, first thing is model, okay? And then we've got our X and our Y. And now we do want to set the scoring for this because, right, when you're dealing with a regressor, I like to use the negative root mean squared error. That's kind of the standard. So if we write down scoring equals, and oh man, sometimes I forget like what we need to put in. Is it the mean squared error, negative mean squared error? I believe it's actually the negative mean squared error. I can actually check it. You know, let me just show you all what I sometimes check here is, you know, these, if I go back, say on the GitHub page, and, you know, I just go into the folder itself, we see IPy, Y, and B. That's like a Colab notebook. That's an IPython notebook. And it's going to have more info than we're going to cover in this session, but it has like a lot of overlap and a lot of code. Okay, so this is all good code, and you can look at a lot of it. You can see here, here's the bike rentals, but it's looking at some other data sets. And note it is the negative mean squared error here. That's what I'm seeing. And note also that when you have CV equals 1, you can do a cross-validation of 1. It only gives you one fold. Okay. So that's what I was looking for. Negative. It's called negative or neg? Neg mean squared error. Now, I could also have looked this up elsewhere. But like sometimes the code that you have written is the best like reference that you'll have because you've run it and you know that it works. Other than that, I can tell you on average, Stack Overflow tends to give the best results. Copy and pasting code from other sites on average is not, in my experience, does not do very well. It's because things change over time, you know, and also people sometimes publicize things that maybe don't work, that they thought worked. Maybe they didn't check it carefully. Usually things are changing. Stack Overflow, it's you know, voted on by people who code for a living. Okay, so the other thing we want to do is CV, right? The whole point here now is to use the k-fold, right? Because this allows for the same cross-validation. Now, I didn't put in a random state here, but note that if I don't run that again, the k-fold again, then it's going to be consistent throughout everything that follows, okay? I could run this again and get different results because the random forest gives different results. And that's okay. I think the idea is that we want to use the same splits. Okay, so that gives us a negative mean squared error. The standard is the root mean squared error. And so what we want to do, I want to change then, right, the scores equal what? What am I going to do to the scores here? I'm going to make them negative, okay? That's going to turn them positive. And then I'm going to take the square root, which you can do the 0.5 power. And so that will give me the, now, if you like, these are the negative, you know, mean squared errors. Now this is the RMSE. I'll just call it that. So now I get the root mean squared error. And now maybe I'll show both here just out of curiosity. Just print both the RMSE, the root mean squared errors, and the mean. You know, going forward, we may just look at the mean. So recall that to get the mean, it's actually a method. You can just put in .mean. Because I believe this is like a NumPy array. Okay, that's a big chunk of code. Like, let's see if it's going to work. And at this point, too, it's ideal if you're clear about what this code is doing. So sometimes I take moments to actually go over code in a little bit of depth, but let's run it first. And there we get pretty good scores, right? So we get a mean of 670. And you can see, even with it shuffled, there is still some variation within the folds where we've got like these, like 870 and 579. That's a big difference. But we're getting the 679 on average. Okay, so what do I mean when I say like you should be understanding the code? You know, at Berkeley Coding Academy, sometimes, there's emphasis placed on, hey, here's the code, write it down. And that's for good reason because, when you're working at a certain level, the code is actually what matters. It's getting the code right. Okay. I can tell you that, like, when I go to talks on machine learning, I kind of don't care about the talk. I care about the code because the code speaks volumes and talk is just talk. I'm interested in that, but it's different. When I'm at my level, when I want to like learn about machine learning, I want to learn code, okay? Because that produces results. So right here, first line. This initializes a random forest regressor, okay? And if you want to see what that looks like, note that you can print out anything. So print out model. I mean, look, we didn't like adjust the model. We set a cross validation. So this is going to be our initial model. And you see all these parameters, okay? I'll tell you all later about bootstrapping. And these are what we can change, okay? So this is an initial model that basically has these hyperparameters set to these values. Note in some of them, you do have actual values like min sample split equals 2. In estimators, this is going to be a big one for us, is 100. And that means building 100 decision trees. In effect, what this line does is it just says, oh, we've initialized the model. It's a random forest, okay? Just like any initialization in coding. Python doesn't actually require a lot of initialization, but some other languages do. Okay, now what? Okay, so cross-val score. This is some weighty code here, okay? First of all, let's look at the inputs. It's got to score, like it needs a machine learning model. And that's kind of cool. Look, when I highlight it, it says what it is. It's a random forest regressor. Okay, so that's what we chose. So we put it in as the first input because cross-val score scores machine learning models. So you need the model in there. Furthermore, the model is to fit on the data, right? And this is what X and Y are. X are the inputs. These are input columns. And Y are the outputs. So what these three pieces indicate is that we're going to use the random forest regressor to fit the inputs of X on the outputs of Y. Okay? And it says, how are we going to measure how well we did that using the negative mean squared error? And cross-validation has, the whole point of it is not just to do one training fold and one test fold. It's to do multiple folds. So we're using k-fold. What is that? Well, we defined it above. We said, okay, let's just do a split in advance, make a shuffled. We're going to do 5 splits. So what cross-val does then when it hits that is says, oh, okay, we'll do this 5 times. So it's going to create 5 test sets. And it runs through. So it took a little bit to run. It runs through. So what does it do for each test set? It says, I'm going to train on the rest of it, fit X to Y, using a random forest regressor. Okay, do our best. And then I deliver the negative mean squared error. Okay, now we made adjustments to that and said, well, we want the root mean squared error. So we're just going to take the negative of it and take the square root. And so the first fold, the first score it delivered was an RMSE of 650, meaning that the bike rentals estimations were off by about 650 rentals. Okay. And then it's going to go through and does that 5 times in 5 different folds to get the 5 different scores. And finally, we looked at just getting the mean so that we can have that kind of nice 1 score. Okay. So that's in essence what the code does. I wanted to just give us a little bit of an idea of what the 670 means, right? Because how do you know? And I will tell you, root mean squared error is very standard. It's almost shocking that it's not a default, but it has to do with how scoring metrics are defined in general. Um, you know, lower. See, because they're defined based on like R squared and accuracy, where like the higher the better, and so negative. Actually, the higher the better is the closest to zero, and so when you flip it, then the lowest is the better. Okay, that's the general idea. But let's look at now the y. This is what we're trying to predict, the y column, and we can get the descriptive statistics. Okay, so we're going to show y column, or say y stats, and we can see that the mean number of rentals is 4,500, and the standard deviation is almost 2,000. Okay, so look, 670 is actually not bad, right? Because it's like a third of a standard deviation. Okay, and you can see this just gives you an idea of the ranges that you can get, right? And it looks like, if you look at the quartiles, you're getting around 3,000 to 6,000 rentals. Okay, so that's an introduction to a first score on a random forest. And what we'll look at next, I guess, are just some initial ways that we can potentially modify it.